So today we're going to be talking about the chemical equation iron 2 oxide. So before we start actually tackling this equation, we have to understand some basic fundamental chemistry concepts. The first thing is iron 2. This means that iron has a positive 2 charge. This means it has two more protons than it does electrons. Now when it comes to transition metals, there's no way to really figure out what the charge is. Often the problem gives it to you because there's exceptions when it comes to metals. There's not necessarily as much rhyme and reason when it comes to the gases and liquids. So oxygen, however, oxygen has a negative 2 charge, and it's in group 16. The reason it has a negative 2 charge is because oxygen has 8 electrons and 8 protons, and it has 2 electrons in its first shell and 6 in its second shell. And the reason it has a negative 2 charge, even though you would think it at first is balanced, is because the whole goal of oxygen, like all other atoms, is to have a complete outer shell. Now the way it does that, it has to gain 2 electrons because it's easier to gain 2 electrons than it is to get rid of 6 because it wants one complete outer shell. So it ends up gaining 2, so you have 10 electrons and 8 protons, thus giving it a negative 2 charge. Calcium has two electrons in its outer shell and 6 open spaces, and it's easier to get rid of 2 and give it to another atom than it is to try and gain 6. So it gives away its 2 and ends up having 18 electrons and 20 protons, and that's what gives it its positive 2 charge. Now, in this particular equation, there's something you're going to have ionic bonds, and ionic bonds cause two particular elements to join, because with ionic bonds, a positive and negative attract, and that's what causes the bonding. I'll explain that more just here in a second. But keep that in mind that a positive and negative attract each other to combine. So, as we discussed a moment ago, iron has a positive 2 charge, and oxygen has a negative 2 charge. So what happens is because iron has a positive 2 charge and oxygen has a negative 2 charge, these two, because both of them have one has a positive 2 and the other has a negative 2, they're able to join together. If this was a 3 and this is a 2, you'd have to start adding coefficients. You probably or subscripts, and the whole problem would change. But for this particular situation, we got lucky, and it's a 2 and a 2, so these easily combined. But keep in mind that they have to have the same number, and one has to be positive and then it has to be negative. Now calcium over here, it's not bonded with anything, so it can just be by itself. You don't really have to change it or mess with it. It's just a positive 2 charge. But this is going to play a role in a second. So this arrow represents change in the equation, and it represents chemical reaction. This is what this arrow represents. And down here, this is where the chemical reaction changes. So calcium replaces iron. Now the reason it can do this is because iron, along with calcium, they both have a positive 2 charge. So it's able to replace this positive 2 here because both of them have a positive 2. And iron over here has a positive 2, so it's just like calcium, it can stay by itself. You don't really have to mess with it. Oxygen has a negative 2, so it easily binds with calcium. And this particular type of chemical reaction is called a single replacement. And the reason it's called a single replacement is because this iron is replaced by calcium. It's replaced by calcium. This calcium right here. This calcium replaces this iron, and you can see that down here in this equation. Now you have other types of equations. You have combustion, you have double replacement, you have synthesis. But since only one atom is being replaced by another one, it's just a single replacement. So I hope you enjoyed watching, and thank you.